So here are two examples that apply the idea of derivative as well as slopes of tangent lines. But in the act of finding the derivative, there's two new techniques that we need to look at. Find the derivative of f of x is equal to 2x times x squared minus 5x plus 2 when x is equal to 2. So notice what's new here. Multiplication. None of those four rules that were mentioned at the beginning of the section discuss multiplication. So you need to write this in a form that you can use the rules. And the only bigger rule that we have is addition and subtraction. So can you rewrite this so that way there is no addition and subtraction? Yes. When you distribute the 2x through, you're going to have a term plus term minus term, and you're good. So, not f prime of x, but f of x is equal to 2x to the third minus 10x squared plus 4x. You were not able to answer this any other way. So when you're given examples, please make sure that it's a term plus a term minus a term, not a product. Because we don't have a rule just yet for product. Remember, see how you have product? If something times something. You don't have a rule for that. You only have a rule for plussing and minusing of terms. Now, let's use the rule. The derivative is 3 times the 2 is 6x, take away 1 from the exponent, squared. Great. 2 times the 10, keep the minus sign, minus 20. X, take away 1 from the exponent, 1. Remember what we said before? If x is to the 1 power, the derivative is just the coefficient in front, plus 4. Now they want to know the derivative of f of x when x is 2. So that means f prime of 2 is 6 times 2 squared minus 20 times 2 plus 4. Evaluating expressions. Plug them in. Substitute them in. Evaluate it to f of 2 will be 6 times 4. 2 squared is 4 times 6 minus 20 times 2, which is 40, plus 4. So f prime of 2, 24 minus 40 plus 4. 24 minus 40 is going to give you a negative number. It's going to give you a negative 16 plus 4. And that gives you a negative 12. Slopes could be negative, right? So that's your negative slope, negative 12. Now let's look at the next example. Find the equation of the tangent line. Different than just finding the derivative at a point. Find the equation of the tangent line to the curve y is equal to 3x squared minus 2 over x when x is 1. And you say, hold up, we didn't talk about quotient. We talk about division. No, we haven't. But we did talk about plussing and minusing of terms. So since you have a monomial in the denominator, remember you could break this up and write this as 3x squared over x minus 2 over x. That's doable. So you want to instead think of this as, this is not a derivative, everybody. We're just rewriting it so that way it's a term plus a term. Simplify it, just to clean it up. Because remember, you don't want division, right? So this is 3x squared over x is 3x. And what did we say before? If the variable's in the denominator, you need to bring it up to the numerator. The exponent to 1. So when I move the whole term up to the numerator, it becomes x to the negative 1. So 2x to the negative 1. Make sure you get that. You're dividing by monomial. So we can't do any of our differentiation rules that we have so far. We don't have a rule for a quotient just yet. So we have to make sure that we divide each term by the x. That brings us here. Simplify it, and this is your y, not your derivative, not your derivative. All you did was rewrote the expression. Now here's your derivative. The derivative of 3x is 3. Negative 1 times a negative 2 plus 2. X, negative 1 minus 1, negative 2. Which is 3 plus 2 all over x squared. The reason why I wrote it like that is because they want me to do more with this. Remember that this is going to give you your slope of your tangent line at a point. We want the slope when x is 1. So to continue with what we had done in the previous section now, the slope of the tangent line is going to be 3 plus 2 all over 1 squared. And again, you could have put in your calculator this, substitute the 1 in, and also if you know 1 to any exponent is going to be itself. So you could have also evaluated that way. 3 plus 2, 5. So now we go to plug it into the point-slope formula. Y minus y1, we don't have an x value, or y value, right? All they gave us was an x value. So we'll come back to that in a second. Equals m times x minus x1. And what am I reiterating as I'm saying that? I'm saying the point-slope formula. So my m and my x. I don't have my y. How can I find a y? I'm given an x. If you substitute the 1, you're going to get the y value when x is 1, just like you would have done back in the day. So you just have to remember to do that. So to find that y value, we look here and we say, okay, when y is going to be 3 times 1 squared minus 2 all over 1, which is going to be 3 minus 2, which is 1 all over 1. So that's 1. So I'm just going to come here and I'm going to do this. 1. And that's my answer. If you did the slope-intercept form, you got 5x minus 5 plus 1. So you would have gotten y is equal to 5x minus 4. However, that's a marvelous answer just in point-slope form. So just to recap, what's super important here, if you have a product, make sure you distribute through so it looks like it's in a form that you can use the 4 rules for. If you have a quotient, again, make sure you divide each term by that monomial and denominator so that way you can use the rules. We're only going to be given examples now that you can manipulate and to use the rules that we've worked with. Eventually, we'll have different questions and we'll have some new rules that we'll have to give you. But make sure you're comfortable with these and you can practice and do these on your own.